Hello, friends. So today, let's talk about one-way ANOVA test. So that is usually done when you've got more than two arms in a particular study. And so that is one scenario. And the other scenario is that the data is not normally distributed. We will talk about normal distribution in the next video. But let's talk about a one-factor ANOVA test. So this is an example of a particular medications rather used to treat high blood pressure. And once you have administered the medication for a certain period of time, you are getting the mean blood pressure. So what now, because there are three arms here, so we will do an ANOVA test. This is to determine whether the mean blood pressure of the three groups is significant or not. Okay. So what we do is we click on data analysis, click on ANOVA single factor. Okay. And then you click on this, drag these three groups, click again on this, and then because we've collated the data in columns, so you click columns here, labels, yes, the first row has labels there, and alpha, which is the p-value, we have set it as 0.05, and we will get the data in another worksheet. So this is all done. We click OK, and this is what you get. Now, what you need to focus on is, look at the means here. So the mean for placebo is this, and then for medicine 1 is this, and medicine 2 is this. So this gives you an idea that which the mean blood pressure of which medicine is within the normal range, potentially. Right? So as you can see that in medicine 1, the mean blood pressure is within the normal range compared to medicine 2. However, is this significant? So for that, what you need to do is look at the second section here. So you have the F value and the F critical value. So if you look at the F critical value, this is 3.35, right? And the F value is 18. If the F value is greater than the F critical value, which means that yes, the mean is significant, right? However, is this statistically significant? Then you see the p-value. Now, if you look at the p-value, it's 1.02 e minus 0.05, which means, let's put it here as an example. So if you look at the p-value, it is actually 1.02 times 10 raised to minus 5. Okay. So then if you divide that 1.02, say, let's just take a random example, 1.02 divided by 10 raised to 5. So 1, 2, 3, 4, 5. If you do this, definitely your p-value will be 0.1234, which is way less than our target p-value, that is 0.05. So here the p-value is 0.001, right? So what you can see is, number one, the F value is greater than the F critical value, which shows that the mean is significant. And number two, the p-value is less than 0.05. So definitely this data is statistically significant. Now, so what was the hypothesis? That the mean blood pressure, there is no significant difference between the mean blood pressure of the use of these three different medications. However, we have rejected that null hypothesis, and we can say that yes, the mean blood pressure of these three medications is statistically significant, where potentially medicine 1 works well In blood pressure, because the mean blood pressure is lesser and it is within the normal range compared to medicine 2, where the blood pressure still remains uncontrolled despite the use of medicine 2. So medicine 1 is potentially more effective than medicine 2 and also more effective than placebo. However, not only it is effective, but it is statistically significant as well, right? So how would you determine whether it is statistically significant? You need to look at the F value, the F critical value, and the P value. So when you do the one-way ANOVA, what you need to bear in mind is you do the analysis properly, and then once you've analyzed, you look at the mean value, then you look at the F value, the F critical value, and the P value. That's it. I hope this was useful, and I'll see you again in the next video. We talk about normal distribution and bell curve. Thank you very much for your time. Take care. Bye-bye.